Hello Hussam. So this is going to be my presentation for the third chapter. I don't think it's the third chapter of part one, which is processor architecture. So let's get into it. So the chapter is just like the other chapter, kind of explains the hidden behavior or the complexity that is hidden away by a certain stage of computing. This hidden is useful for programming, but you have to understand, you have to know the hidden complexity in case you need in case you have to deal with certain rare problems that occur. So in the previous chapter we saw that C hides the machine. In this chapter essentially it simply hides the processor. A good analogy is that whereas a human brain thinks in sequence, one thing happens, then the next thing happens, and then the other thing happens. Electrons don't behave like that. Electrons, it's everything happen all at once, and this creates and the processor, or the processor as it's designed, it is designed to kind of handle these problems so that it runs smoothly, but in doing so it is essentially lying to you. This lie or this illusion, just like previous illusions or previous abstractions, are useful for general programming, but in case there are certain issues you must know so that you don't fall into these. The chapter is very well explained. It kind of does not give you accepted terms and builds on those terms to kind of teach you assembly or teach you the architecture of a processor. It kind of goes from first principles using its own modified version of x86. But the chapter is very well done, but this is what I got away. This is what I think is most useful for programmers, is that you have to think about it as the processor is lying to you. The main lie is the problem of time, or rather sequencing. These essentially are the same thing. Is that as I explained, electrons kind of move randomly all around, and the processor kind of tames these behaviors into something that is workable, and presents a illusion of sequence. And there is no, the illusion of sequences, as the name implies, an illusion. And for the most part, you can work well with it if you follow the best practices. But you might need to know how the machinery works under the hood in case you have to debug a very serious problem later on in your career. Obviously, these are edge cases mainly we're going to talk about. So first of all, what is the notion of time in the processor? Essentially is that time for the machine is kind of periodic. So there is the tick of the clock, because the machine has an internal clock, and there is the time in between ticks. In between ticks, the machine is in a state of combinatorial logic. Essentially is trying to maintain, trying to kind of reorder everything while there is no state. And in the tick, this is where registers and all the modes of state management come into life again. And this is kind of the ping pong of the machine that it does it does while it is running. And the other problem with the notion of time is that the instructions are not a single event. There are various stages in a very simple instruction in assembly. So fetching, decoding, write back, everything. And most of these instructions are running simultaneously, because once again, electrons are not like human brain. And this is if you are struggling to understand how this is true, this is your cue to understand that electrons do not behave in the same way we are programmed to think. They do not behave sequentially. They behave everywhere, every time, all at once. And this leads to the lie that the processor is maintaining. And let's go by an example. First of all, we have instruction B, and it needs a value from instruction A as an input, but instruction A has not reached the write back stage. So the fix the processor is implementing to kind of get these instructions to behave like a sequence is the idea of forwarding. And the idea of forwarding is essentially you kind of take something from the future and you send it back to the instruction that needs it, bypassing the register. And the key insight you can derive from this behavior is that the sequential nature of assembly. For example, you have a move AX to BX, you have a kind of incrementation, you have a load effective address. All of these sequences are not actually sequences, because first of all, these are multiple operations that are overlapping, and second, these overlapping operations for each instruction are happening simultaneously, and they might need information they do not have. And while forwarding kind of solves the problem 99% of the time, there is a small chance that there's going to be a problem somewhere else. And once again, the processor is designed to kind of preserve this lie because it is a useful illusion. You won't need the truth 99% of the time, but it serves you to know it in case you need it. A better framing I found to kind of tell yourself, once again, I believe that it is also very good to tell yourself that the processor is lying, but it is also a good idea to kind of see the processor as an active participant in the mental infrastructure, in the mental model that the community has built for coding. This makes programming much productive. The mental model, the community as the computer science community has created, makes programming a lot more productive, but it is also kind of hides a certain level of complexity, which is why it makes coding productive. And the processor itself, being a designed feature by the human, is also a participant in this mental model we have built. And for just I'm going to go to certain potential issues you can get from the lie that the processor is telling you. Generally, it's essentially just a problem of speed, so the processor has to maintain the lie, but there are certain cases where it cannot lie enough, and it has to resort to certain issues. The to certain behavior that present issues. The first behavior is the pausing, which creates bubbles, where essentially, as we explained earlier, instruction A is waiting for instruction B, but instruction B has not yet achieved write back stage. So what happens? The hardware pauses, and this kind of creates a gap in the processor, in the cache, and this can lead to problems. The other problem is that the machine can't wait, because once again it cannot pause and it cannot wait, so what it does is start to guess. This is also another problem, and both of these issues have their fair share of problems. They can be categorized into either performance issues or security issues, because the speculations leave a footprint in the cache, and obviously this is very rare, but very costly, which is hallucinations, which is where the program kind of gives you things you're not expecting. And so, if we are to summarize, what is the main takeaway is that there is a philosophical mismatch between the human brain and the machine. It is structurally so, because you cannot make the machine is not similar to the human brain. We have to bend the machine to kind of play to our mental model, and this is not something you can fix. But you must also keep in mind the machine way of thinking while you are programming. A beneficial way to frame this also, and I believe in framing because, rather than to remember stuff mechanically, it is better to kind of tell yourself a story, and this makes remembering and kind of dealing with it much more simpler. It is in a sense a form of lying or a form of abstraction, because it's a form of bending reality to the way your brain works, because people are better with stories, so it's better to kind of frame things as stories with entities and stuff, and the processor is a physical or a real entity that's kind of lying to you. But this ironic. Essentially, you should behave as if you are not writing code for a processor, you're writing code for a pipeline manager, and the pipeline manager has to handle things that are not that are not intuitive to you, for example. This is a good way to say it. So they have to have to forward stuff, you have to jump, they have to guess sometimes, and you have to maintain that in mind so that when you write code that is structurally safe and does not have issues. And this has been my presentation. Thank you for watching.